Okay, we just wrote down check for extraneous solution. Here's what an extraneous solution is. Extraneous solution is an answer that you get, but when you plug it back in, it does not work.
What?
Okay, now why does this happen? Well, it kind of comes from the idea of when you square root something, you could potentially have the positive and negative, right?
True.
Okay, so it kind of comes from that idea that if I get something, and really, I'll be honest with you, it's only square root. Okay, it's only square root that we need to check it. Okay, or an even root. We need to plug it back in to see if it works. If it doesn't work, then we're going to omit that answer, and you'll see that in some examples as we go further along. So example 1. What do I need to do first? I'll just say this, guys. I don't want to square both sides. We're thinking, oh, I got to get rid of the square root. I want to square. The only time we're going to square both sides, can't say the only time, but we truly want to get only the square root on both sides before we square it. So I need to get rid of the 2. We're going to divide both sides by 2 right away. And now I'm left with the square root of x plus 1 equals 2. How do I get rid of a square root? We're going to square both sides. So when I square both sides, the square and the square root go away, and I'm going to be left with x plus 1 equals 4.
Minus 1.
We can minus 1 on both sides. And x equals 3. Okay, so now, there's our answer. We need to go check it. We should plug it in. 3 plus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. It works. Questions there? What should I do first here on the second one? We're going to add 1 to both sides. Get that 1 over to the other side. So now I have the cube root of 2x minus 9 equals 3. How do I get rid of a cube root? Yeah, we're going to cube both sides. So the cube and the cube root go away. So I'm left with 2x minus 9. What's 3 cubed? 27. And now we can solve that from there. Go ahead. Finish that one for me. I think we get 18, right?
Yes.
Okay, since it's a cube root, we don't need to necessarily check it. Is there always an option? Yes. We don't need to check for extraneous if it's cube, only if it's squared. Questions there? Tristan?
So it will always work if it's cubed?
If it's cube, yes, we don't need to check. If it's squared, or I guess I should say an even root, we should check it. Okay? Example 2. How do I get rid of the square root? And you square it, okay? So I'm going to square both sides. And on the right side, the square root goes away, so I'm just left with 7x plus 15. And on the left side, guys, here's a question. Everyone watch. Can I take and just do this? No. Okay? No, you can't do that because there's plus there. What do I need to do here?
You have foil.
I have to FOIL, right? I need to write it out twice. X plus 1 and x plus 1. Have to FOIL that. So when I FOIL, I'm going to get x times x, which is x squared. X times 1 is 1x. 1 times x is 2x, plus 1, and that's going to equal 7x plus 15. Now, anytime you have x's and x squareds, what do we need to do? Autumn? Any ideas? Guys, if I go back up here, I never had any x squareds. So I can just get all my x's on one side, all my numbers on the other. But as soon as I had x squareds and x's, now everything's got to be equal to the same, or on the same side, and needs to be set equal to 0. Right, Sam? Yeah, set equal to 0. So I'm going to move everything over to the left. I'm going to minus 7x, and I'm going to minus 15. Minus 7x, minus 15. So I'm going to get x squared minus 5x minus 14 equal to 0, and now I'm going to try to marf it. Is this marfable?
Yeah.
It is. Factors of negative 14 that add up to negative 5 are going to be negative 7 and 2, right? So this is mini marfable. I'm going to make this an x, make this an x, minus 7 plus 2 equals 0. So that means my x value is going to equal 7, and x is going to equal negative 2. Now, I need to check my answer. So here we go. I'm going to plug in 7. If I plug in 7 here, I'm going to get 8, right? On the left. That's pretty easy. Now, over here, 7 times 7 is 49. 49 plus 15. 64. Square root of 64 is 8. That works. I like 7. Let's see if negative 2 works. Negative 2 plus 1 is negative 1. 7 times negative 2 is negative 14. Negative 14 plus 15 is negative 14 plus 15 is positive 1. So I'm going to get the square root of 1, which is 1. Does that equal? No. Therefore, negative 2 is extraneous, and I'm only concerned about 7. So here's your first example of an extraneous solution. Negative 2 does not work. When you plug it in, it doesn't come out to be a true statement. Kind of call that extraneous. We're only worried about 2. Tristan.
So we just cross it off?
Yeah, we're omitting it.
We don't try and make it work or anything?
It can't work. Nope, yeah, can't work.
Oh.
Questions there? Here's where it gets fun.
Yeah.
First of all, notice this. I have 2 square root signs, right? 2 separate square root signs. Now, to get rid of this, I can square both sides. But understand this. When I square the right side, I also have to square the entire left side. I can't just square this. I have to square the entire side. Okay? So when I square this left side, I have to square all of that.
So why don't we just cancel one square root and then do the thing twice? Because it's like FOIL or something.
Yes. We're going to, this cancels off. This just cancels. But now I have to write this twice. I have to write the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1, and that's going to be equal to, after my square root goes away, 3 minus x. Now, we need to FOIL on the left-hand side. We're going to treat square root of x plus 2 as one thing. So when I FOIL, I'm going to take square root of x plus 2 times the square root of x plus 2. What's that? That's x plus 2, right? You take a square root of anything times itself, square root of. times itself, and you get whatever's inside. Square root of x plus 2 times square root of x plus 2 is just x plus 2. Square root of x plus 2 times 1,
Square root of x plus 2.
that's just going to be the square root of x plus 2. Again, we're still foiling. 1 times the square root of x plus 2 is going to give me plus square root of x plus 2. And then lastly, 1 times 1 is 1. And I have 3 minus x on the right. So we've foiled on the left-hand side. Now, let's combine like terms here. I have a 2 and a 1. I can make that to be a 3, right? Now check this out. Don't I have 1 of those plus 1 of those? Isn't there a 1 in front here?
Yeah.
So if I have 1 Mountain Dew plus 1 Mountain Dew, I have 2 Mountain Dew. So I'm going to add my 2 and my 1, and I'm going to get x plus 3. And then I'm going to add my Mountain Dews. Not an equal sign. It should be a plus 2 of them. Any questions so far? Big idea. We got to foil this big thing. When we do that, I'm left with that. Now here's the deal. Same question?
Will we have to move the 3 to the end?
Say it again.
Will we have to move the 3 to the end?
Let me keep going and I'll see if I answer your question. I still have a square root, don't I?
Yeah.
So eventually I'm going to have to square that to get rid of that again. But before we do that, let's try to get rid of everything else to the other side. So what I'm going to do is I'm going to minus x on both sides, and I'm going to minus 3 on both sides. So when I do that, I'm left with 2 times the square root of x plus 2 equals 3 minus 3, well, those go away, equals negative x minus x is negative 2x.
Now we squared? No, we didn't.
Okay? At this point, you can do two things. We can either square both sides or we can divide by 2. Okay? Now, this is my first time rolling through this textbook, and I don't know how the problems are going to be. So, could we divide both sides by 2 here?
Yeah.
That would work. But check this out. Let's just pretend for a second this was a 3. Now does dividing by 2 work so nicely?
No.
It doesn't. Because now I'm going to have a decimal over here, a negative 1.5. Okay? So, absolutely, and I'm going to actually show you guys both ways, we can divide by 2. If things are divisible, let's divide by 2. So those are going to go away, and now I get the square root of x plus 2 equals negative x. Now, how do I get rid of the square root?
Squared.
We're going to square both sides. So here I'm going to get x plus 2 equals x squared. Because anything negative squared becomes positive. Okay? Now I have an x squared and an x, so let's get everything onto one side. I'm going to move everything over to the right because I like a positive x squared. So I'm going to minus x on both sides and minus 2. So I get 0 equals x squared minus x minus 2. And now I want to try to factor that. What are factors of negative 2 that add up to negative 1? Isn't this x minus 2 and x plus 1? Right? And so then my x values are x equals 2 and x equals negative 1. Are there questions there?
And you're going to show scenarios?
Say it again. Yep. And before I check my answers, I want to show you the other way here in a second. So we're at this part. where I have 2 times the square root of x plus 2 equals negative 2x. So I'm going to show you the other way to do it. So this idea works great when I need to divide by 2 and that's divisible by 2. Another way would be to square it. Okay? To square it right away. So when I square both sides, do I have to FOIL this?
Yeah. Wait.
The answer is no, because I'm not adding or subtracting there. It's multiply. So when it's multiply, that means I can square both of those things. So 2 squared is 4. The square root of anything squared is just going to be left with x plus 2. And now same idea here, there's multiplication there, so I just need to square both things. So I'm going to get 4x. Now I need to divide both sides by 4. I'm going to get x plus 2 equals, this should be x squared, equals x squared, and we're going to go from there. Okay? It's not going to change your answer, but by squaring both of them, sometimes it'll get rid of that potential extra decimal fraction and so on. Okay? Well, so let's go ahead and check this. I need to plug in positive 2 and 0. Okay, positive 2. 2 plus 2 is 4, and the square root of 4 is 2, and 2 plus 1 is 3. So I get 3 there. And then 2, so 3 minus 2 is 1, square root of 1 is 1. So does 2 work? No, it doesn't. We better check negative 1. Negative 1 plus 2 is 1. The square root of 1 is 1. Plus 1 is 2. 3 minus a negative 1 is 4. The square root of 4 is 2. So does this work? It does. Guys, I did all that in my head. If you're struggling with that, or golly, I don't know, write the darn thing out and just do it by hand. Okay? Because I'm just letting you know it's going to come to a point in the assignment where you got to put in your answer, and you're either going to put one answer or 2 answers, and you're going to have to see if there's an extraneous solution. And you're going to get it wrong, okay, because we did something wrong checking our answer. Negative 1's our answer. Questions there? Refer back to that example when we get one like that on our homework. Top of the next page, I've got 2 left, and then I'll give you some work time.
We're not doing 5?
Say it again?
We're not doing number 5?
I've got 2 left, so I guess 2 examples, meaning I've got 2 here, but these roll quickly. Now you notice we have rational exponents, okay? Now, first we need to get rid of the 2. So I'm going to minus 2 on both sides first, and I get 2x to the 3/4 power equals 8. Okay? Now, if I had this, guys, I'm making this up. How do I solve for x? Essentially, how do I get rid of the fraction? I multiply by the reciprocal. So if I were to multiply both sides by 4 over 3, those go away, and then I have to multiply by 4 over 3 on that side. Same idea. How do I get rid of this nasty exponent? Well, I'm going to take the whole thing to the... Let me move this over for a second. I'm going to take it to the 4/3 power. And when I do that, I have to do that to both sides. So now, when I take something to the 3/4 power and take the same thing to the 4/3 power, they go away. They cancel. So now I'm left with 2x on the left, and then this 8 to the 4/3 power. But remember, the 4 represents my what? Isn't this my power over root? Power over root. So I'm going to make this the cube root of 8 to the 4th power. Instead of having a radical, or excuse me, a rational exponent, I change it to a radical. Power over root. Now, what's the cube root of 8? 2. What's 2 to the 4th power? 16. So this whole thing is just 16. So now I get 2x equals 16. I can divide both sides by 2. And x equals 8. We better plug this in. What's 2 times 8? 16. So now I'm going to take 16 to the 3/4 power, power over root. So I'm looking at the 4th root of 16 cubed. What's the 4th root of 16?
2.
That is 2. 2 cubed is 8. 8 plus 2 is 10. It works.
Are there going to be ones like that where they don't work on the assignment in this kind of example?
I don't know. I don't know that answer. Okay? Now this last one. How do you get rid of the 1/2? Well, we're going to multiply both sides by 2 over 1 or just 2. We just need to square both sides. So those are going to cancel. I'm just left with x plus 30 on the left, and I'm left with x squared on the right. I'm going to get everything to the right, so I'm going to call that x squared minus x minus 30 equals 0. And now I can factor this. Factors of negative 30, that add up to negative 1. Should be negative 6 and positive 5. So then x is going to equal 6 and x is going to equal negative 5. Guys, and here's one thing I'll tell you. Anything that's 1/2, anything with a numerator of 1, that's just like the square root. So 1/2 is the same thing as square root. 1/3 is cube root. 1/4 is 5th root. So really, this is, if I take this away, this is just the square root of that. Okay, so to answer Tristan your question, it says, do we need to check our answer? You do. Because a radical could be as a rational exponent. So if I plug in 6 here, okay, 6 there and 6 here, 6 plus 30 is 36. The square root of 36 is 6. Does that work? It does. If I plug in negative 5, negative 5 plus 30 is 25. Square root of 25 is, so I get 5 equals negative 5. That doesn't work. And last example here. Read that by yourself, please. Guys, when you come across something you don't know, just keep reading. Okay, so this is in a hurricane, a mean sustained wind. What's mean mean? Like it's not nice? What's mean mean? Mean is average. So in a hurricane, the average sustained wind velocity, V, in meters per second, can be modeled by this function, where P is the air pressure in millibars. I don't know what a millibar is. It's some type of measurement. At the center of the hurricane, estimate the air pressure at the center of the hurricane when the average sustained wind velocity is 54.5 meters per second. So 54.5 meters per second, that goes in where? v, because that is velocity. And this is a function for velocity. Okay? So I'm going to plug in 54.5 in for v of p. So this whole thing is now being replaced with 54.5. Set that equal to 6.3 times the square root of 1013 minus p. And our goal is to solve for the air pressure, which is p. So how am I going to do that? Yep, we're going to divide both sides by 6.3. Help me, I have a calculator up here. Does that round evenly? Okay. Does it round to 0.65 though? Now we're left with this. Now, what do I need to do to both sides? Guys, I'm really picky about getting the most accurate answer possible, almost probably to a fault. But we rounded this, didn't we?
Yeah.
And I know I need to square both sides. You should have this number in your calculator, right? Square the actual number. Don't square the rounded number. Because if you round and then start making other calculations, it throws your error off dramatically.
No,
So square that number. What?
if like I did it 8.65 like and squared it and got that answer put in the computer, is there a chance it'd be wrong then?
I don't know how the computer with the answer, how far off they allow. So you should square that. Now I'm okay with you rounding that. So, which my calculator worked on here, but it doesn't. So now I get 10,013 minus p. What do we get here? 0.84. Now I'm going to minus 1,013 from both sides. So on the right, I'm going to get negative p, and on the left, it won't matter. It won't matter. Help me out there. What do we get? Negative 0.16. So that means P, which is our air pressure in millibars, is 937.16. So we don't get 937, we get 938. So this should be negative 938, and then when we flip our sign to get P, it should become positive there.